So what we're really looking at is the probability of seeing certain data values given a category and the probability that a data point is in a certain category. And both of these things are things that we can calculate from our data set. So let's look at this specific example. If we want to classify something as having a heart attack or not having a heart attack, we can calculate the probability of having a heart attack given that someone is a smoker, they're diabetic, and they're obese. And we can calculate the probability that they did not have a heart attack given that they are a smoker, they are diabetic, and they are obese. Now, when we calculate those probabilities, all we have to do is choose the probability that is higher, and that's the category that we would classify our data point as. Now notice that in these two formulas, the denominator is exactly the same. That means that we can ignore this part of the formula, because in essence, if you're just comparing two things to see which one is bigger, if you multiply them or divide them by the same thing, the one that was bigger is always going to be bigger. The official term for this is that we say the probability of a heart attack given that you're a smoker, diabetic, and obese is proportional to the probability that you're a smoker, diabetic, and obese given that you had a heart attack times the probability that you had a heart attack. So just as a reminder, we can calculate these two portions from our data set. So for instance, if we want to calculate the probability of someone being a smoker, diabetic, and obese, given that they had a heart attack, all we have to do is look at our data set, look at all the people who had heart attacks, and calculate the probability or the proportion that were smokers, were diabetic, or were obese. In the same way, we can calculate the proportion of people that had a heart attack by looking at our data set and calculating the proportion of people that had a heart attack. And this goes the same for people who did not have a heart attack. So, in essence, we are going to calculate the probability of a category given some data based on things that we can calculate directly from the data. So that was the Bayes part of the naive Bayes algorithm. Now let's talk about the naive part. So the naive part of the naive Bayes algorithm alludes to the fact that we ignore the relationship between our predictor variables. For example, imagine that we're trying to predict the probability that someone is a smoker and they're diabetic. Well, in the real world, we would need to think about the fact that being a smoker and being diabetic might have some kind of relationship. It could be that being a smoker increases your chances of being a diabetic, or maybe reduces them, we don't know. However, we know that there probably is a relationship, and we have to take that into account when calculating the probability of the two things happening together. However, the naive Bayes algorithm is naive because it pretends that those relationships don't exist. So for a given category, it tells us to assume that there is no relationship between diabetic and smoking, even though we know that there probably is one. In other words, it assumes that within a category, these variables are independent. Now this makes our math and therefore the computational efficiency a lot better, because when we calculate the probability of someone being a smoker and being diabetic, now all we have to do, because we're assuming there's no relationship, is to multiply the probability that they're a smoker times the probability that they're diabetic. Okay, so now we've covered what the Bayes part of the naive Bayes algorithm which basically says for ham emails and for spam emails. What is the proportion in our data set that have these 4 words? And for time's sake, we're only going to look at 4. So for instance, we're going to look at the word Viagra, the word love, the word dollar, and the word buy. So for example, in our data set, for a spam email, the probability of seeing the word dollar is 0.83 or 83%. And the probability of seeing the word love, given that we are looking at a ham email, is 0.36. So let's do the math to try and classify this email, which says, "Hello, I had a really great day. I would love to buy you lunch. Let me know." So the first thing that we have to do is calculate the probability that the email is a ham email. So I'll write that here, ham. Oops, there we go. Now, the first thing that we can do is multiply the probability that an email is a ham email. And I don't have this in the table, but I'll just tell you, in this data set, the probability that an email is a ham email is 50%. So we'll start with 0.5. And then we'll go ahead and multiply that by the probability of seeing an email without the word Viagra, with the word love, without the word dollar, and with the word buy, given that it's a ham email. Okay, so the probability of an email that is a ham email not having the word Viagra is 1 minus 0.03. And then we're going to multiply that by the probability of the word love appearing in a ham email, which is 0.36. Then we're going to multiply that by the probability of not seeing the word dollar, which is 1 minus 0.02. And finally, we're going to multiply that by the probability of seeing the word buy, which is 0.02. And when we do all of those calculations, you can see that we get a score of 0.00342216. And remember, this is not the probability of an email being ham email. It is proportional to that probability. Okay, so now for the spam email, we need to do the same calculation. So first, we'll start off with the probability of an email being spam, which again is 0.5 in this data set. And then we'll multiply by the probability of not seeing the word Viagra times the probability of seeing the word love times the probability of not seeing the word dollar times the probability of seeing the word buy. And when we do all of that math, we get that our score is 0.002138.6. So now that we have our categories and we have our scores for each category, all we have to do is choose whichever one is higher. And in this case, the score for ham is a little bit higher. So we're going to classify this email as ham. Okay, now that we've done an example, hopefully you have a little bit of a better idea of how the naive Bayes algorithm works. So, just to review, the 2 important things to remember are that the naive Bayes algorithm uses Bayes' rule to calculate probabilities of a category given certain values of the data. Second, the naive Bayes algorithm is naive. It assumes that the variables that we're using to predict are independent for any given category. Okay, by the way, you can see that I had all my math written down on this post-it, but I'm done with it and I don't need it anymore. Okay, thank you for listening this naive Bayes lecture, ASMR style, I will catch you